Hello, everyone. Welcome back to the AAS YouTube channel. And this is part of the good stuff. This is part of the great stuff. This is the AAS Journal Author Series. And I am delighted to have Yujie Lian and Zhichen Pan with us today. I'm sure I butchered those.
Yeah. Hello, everyone. Hello, Frank,
Hello.
and thanks very much for this invitation. And I'm very happy to be here. Yeah.
Well, Yujie, thank you. And Gigi, thank you so much for agreeing to talk about your very lovely article, which we'll
hmm
get to here shortly.
hmm
And Yujie, let's start with you.
Okay.
What's your geolocation?
Actually, I'm currently on Bonn, Germany, and I'm a visiting PhD student here at Max Planck Institute for Radio Astronomy. My formal PhD will be in Beijing Normal University, the School of Physics and Astronomy. Yeah.
Very nice. Very nice. How is the summer in Germany?
Oh, actually, today is quite rainy, so the weather is very cold, I suppose, in September. So it's freezing. Yeah.
Oh,
Uh-huh.
we're already getting into fall.
Yeah. So,
Yeah.
yeah, yeah.
Wow. Very cool. And let me
hmm
ask, since you said you were a PhD student, when do you anticipate
hmm
graduating?
Actually, I will do my PhD defense at the end of this November, and it looks only 2 months left. Yeah. Thanks.
Well, let me be the first to congratulate you, Dr. Lian.
Okay. Thanks very
You're
much.
very
Yeah. Okay.
welcome. Very cool. Very cool. And Gigi Chen, what's your
Hi.
geolocation?
I'm in Beijing, China, and
Cool.
the time here is the afternoon 3 o'clock. And you can see my background is the real my office
That's a
is
real science office. That's a real
uh,
science office.
thank you. And follow you, I wish to be the second person to graduate the graduation of Lian Yujie.
Are you also graduating in November?
No, I was getting my doctor degree almost 10 years before
In
in
years.
the
Okay.
2016.
Well, you look so young and charming, so you know.
Thank you.
All right, very good. And let's see. Let's stay with Gigi Chen. Um,
Yes.
what do you like to do for research?
You mean now or in my whole life?
Whatever you want to talk about. What do you like to do for
Uh,
research?
I was previously amateur astronomer, and those two boxes is the telescopes.
Yep.
And then more than 10 years before, I was lucky to join the FAST group, so that I can start my career with the radio astronomy. And
Cool.
then we started to use the FAST to find the new pulsars, including the first pulsars come from FAST. But that thanks to the very huge sensitivity of FAST. And
Hmm.
then we started to find a pulsar in the global cluster. And till now, we have the current paper about our global cluster pulsar survey.
Cool. Very nice. Yeah, FAST is a fantastic facility. It's just,
Thank you.
yeah, yeah. Let's see. And Eugene, what do you like to
Yep.
do for research?
Yeah, actually, I'm now interested in timing and searching pulsars in global clusters, and I also do some cluster dynamics through the pulsars. And I'm also interested in like studying pulsars with their relativistic effect and to like prove some gravity theories. Yeah.
Very cool. Very
hmm
nice. And that is going to bring us to this very awesome APJ supplement article. It is open access. It's the open access era, people. You can go grab a copy for free. Go get one. The FAST Globular Cluster Pulsar Survey, GC fans, and Yuji and Zhichen, take us away.
Okay, thanks very much. And first, we want to introduce the co-authors. And as you can see, there are four co-authors, and including Haiyan Zhang. She is also a professor in NAOC, and Shuo Cao, he is a professor in Beijing Normal University and my former supervisor. And
Ah,
uh, yeah, and Paulo Freire, and he
okay.
is actually my supervisor in Max Planck, and I am studying with them. And I think Zhichen Pan want to introduce Lei Qian, I think, yeah.
Okay, it's my turn. And Lei Qian is my colleague and stay in the office next to me. And he is also my teacher. And the Riff Yitong is staying in the same office as me, but
Wow.
now he is out for the coffee. Professor Shao Lin is from the Peking University.
Hmm.
He provided many valuable experience and suggestions for our paper.
Cool.
And Scott and Duncan indeed helps a lot with our study.
Mm.
Scott told me how to time the pulsar hand by hand. And Duncan told me that we should use fast to observing those global clusters as long as we can, and
Cool.
resulting so many discoveries. And the following many Chinese names, I will read them one by one, including De Jiangyin, Yin Fendai, Liu Kuo, Wang Ling, Wang Yujie, Zhang Zhongli, and that's called Fan Zhonghua, is the colleague of Professor Zhang Zhongli from Shanghai Astronomical Observatory,
Uh-huh.
and also including Li Baoda, Li Minghui, Liu Tong, Li Yaowei. All these are the people around me. And then Peng Bo and Pan Yu is two professors in our cooperating universities. Wu Yuxiao is the student of Professor Pan Yu.
Okay.
Zhang Liyun is a professor for some students named before, and we still have Zhang Xingnan, who is our previous students worked for our computation.
Cool.
And the last guy, Professor Peng Jiang, is currently the leader of the whole FAST project,
Yeah.
and you should find his name everywhere.
Yes. Oh man, you slugged that like a native. That was great. That was really good.
Thank you.
All right. Great shout out. Great shout out. Okay, let's go ahead and get into it. Pulsars and GCs.
Okay. So, as you know, globular clusters are a gravitationally bounded stellar system, and it containing like tens of thousands and up to millions of stars, and their current densities are very high, and sometimes up to 10^6, and the solar mass. Yeah, and I think so. Such a immense stellar densities will lead to a very high rate of stellar interactions and between stars. Like sometimes the stellar tidal capture and the exchange encounter will happen very often, and this will enable the creation of low mass X-ray binaries, and which is thought to be the prime star of millisecond pulsars. And so clusters are ideal place to searching for millisecond pulsars. And for currently there are 345 millisecond pulsar node in GCs, and it count for nearly half of the all millisecond pulsars node in this in Milky Way. And so it's a very good place to find pulsars. And
Yujie, could I interrupt
mhm,
you?
yeah.
I would like to tell you the numbers. When I started to search for pulsars in the global cluster, from Pulsar's catalog, from Polo's catalog, there's
Mhm.
only 157 pulsars discovered. But now we have more than double the number, and
Awesome.
thanks to the first thing is Meerkat telescope, and then is fast.
Okay. Right.
Yeah, exactly. Okay,
Cool.
thanks for that. Yeah. Okay. So the very special environment of clusters also give birth of some very exotic binary systems. And as you can see, there are currently 56% of the pulsars in clusters are in binary system, and count for 12% in the whole galaxy. And as you can see, there are many very exotic binary system found in clusters, especially for the cluster for the pulsar with the fast spinning period, and the pulsars with very eccentric orbits and massive companions. And
Hmm.
also this cluster contains a very interesting binary system, which is likely a holy grail system. It's like the first ever millisecond pulsars and plus black hole binary,
Oh, cool.
and found by Meerkat.
Cool.
So, yeah.
Very nice.
And I want
So,
also to add some numbers here.
Yeah, please.
okay.
If you go to see the Pulsar catalog, PSR cat,
Yep.
you can list all the millisecond pulsars and all the binary pulsars. And I suppose maybe half of the binary pulsars are come from the globe cluster. And maybe not to the half, maybe 30 or 40% millisecond pulsar may also come from global cluster.
Wow.
So the interesting thing is that the pulsars discovered in the global cluster are all exotic, at least the millisecond pulsar, which is rotating very, very fast.
Yes. Very cool. Good. Thank you. I'm with you. Okay.
Okay, so in the last several years, and there are many, very awesome telescopes has done some pulsar surveys, and I think so. The one fundamental limitation of these surveys is the sensitivity of the radio telescopes.
Yes.
Because as you know, pulsar is a very weak radio source and always distant away from us about several kpc, even tens of kpc. So the sensitivity is very important when searching such kind of weak pulsars. And as you can see, there are new generated facilities like the upgraded giant millimeter wave radio telescopes, and Meerkat, of course, is coming and has done some excellent work for finding GC pulsars. And for FAST, the 500-meter aperture spherical radio telescopes is also attending the campaign to searching GC pulsars. As you can see, FAST is the most sensitive single-dish radio telescopes in the world, and to date, FAST has discovered over 1,000 galactic pulsars, and
Cool.
constituting 25% of all known galactic pulsar population. And the campaigns including Craft, led by Di Li, and the GPPS, led by Han Jinlin, and also the GC Fans project, led by Zhichen Pan and Qian Lei, and all the other
Not
colleagues.
me. We have
Okay.
many people here, and
Yeah.
I want to add something for our trace about the global clusters.
Okay.
Because of the fast sky coverage limitation, we only have 45 global clusters, while the total number could more than 160.
Okay.
So we have no trace and we observed all the global clusters. But it seems that the limitation for discovery the pulsars could be either the distance. For example, currently we find the furthest global cluster pulsar is only 16. Yeah, am I right? I'm 53.
Yeah.
Yeah.
It is somewhere 18 or 16 kiloparsecs. And
Yeah.
FAST definitely have observed many much further global clusters, and we also carefully process the data, but no pulsar discovered. So if you go back to see our discoveries, you can find the furthest global cluster pulsars is still very bright. So we should have the ability to find much more further pulsars, but we need such a sample maybe existed in the sky out of fast reach.
Right. Okay. Cool. Good.
Okay. So as Zhichen Pan says, and GC fans aim to search for pulsars and may be missed by previous surveys due to the sensitivity limitations. So here comes our chapter 2, survey details. So there are 45 GCs visible to FAST, and we have surveyed 41 of them. And actually, we can have a look at table 1.
Table
Yeah.
1. Let's take a look at table
Yeah.
1. I'm going to rotate this. People can actually see it.
Okay, thanks very much. And in table 1, we have concluded all the fundamental parameters of these GCs, and especially conclude the null pulsars in this in 40 GCs. And as you can see, their bolded numbers in the null pulsars is found by FAST, and they also list the sensitivity of searching pulsars in these clusters, as you can see.
Cool.
So thanks to FAST very high sensitivity, we have such kind of so many discoveries of pulsars. Yeah.
Yeah. Beautiful.
Yeah.
The interesting thing is that if the global clusters have the previously no pulsars, it seems that we will have much higher probability to find new pulsars in those global clusters. And by the way, this can be the advertisement. We also have another paper which was in the APJ letter is about our estimation about the global cluster pulsars.
Nice.
And we are closely follow our estimation.
Well, very good. That's always a great thing to have. And we'll put a link below the video to that APJ letter in the description below the video.
Thank you.
You are welcome. You are welcome. Awesome table.
Okay.
Actually, this table, I'm going to rotate.
Yeah, I think we can go back to figure 1. I can introduce the
okay.
target.
By the way, another thing is about the fast data, because we started in 2017, which means we observed for years and we have very large archival data.
Right.
And everyone is welcome to obtain either the published data or the very new data, and you can directly ask me or find my email address in our paper.
Cool. Very good. Yes. Availability of data is always a good thing.
And we are always open to everyone to get access to any data you like.
Yay. Awesome.
Okay.
Okay, let's see. Distribution on the sky, it looks like.
Yeah. Okay, so here this figure shows all the 40 file clusters with by FAST, and this is their galactic distribution. And as you can see, the different color represent they are predicted by a different value of stellar encounter rate, which is a good indicator of the forecasting pulsars, the number of pulsars in this cluster. Yes. So as you can see, for FAST, most clusters with pulsar discoveries are always bit lower encounter rate. So this means with fast high sensitivity, we can find more pulsars.
Okay.
And so actually, we have surveyed 41 GCs, and this brings us 60 pulsar discoveries in 40 of them.
Cool.
Yeah.
Okay. There is an exception about the global cluster M71. The first thing is that we may have at least 4 or even 5 pulsars belong to this global cluster. I think the reason why we find so many pulsars is about the distance. You can see the distance from many references is only maybe 4.5 kiloparsec, which is relatively close. Yeah. And then you can go through our paper, you can find the pulsar discovered in M71 is either the black widow types of the binaries, yes, or either the relatively long period pulsars.
Yes.
So it has totally different distribution of the classical so-called global cluster pulsars.
Very nice.
Yeah, so we will discuss this in later. Yeah. Okay, so I think we can go to the searching of pulsars, like in chapter 2.3, I believe. Sure. Oh yeah, here comes the survey strategy and survey limitation. So I think so for GC fans, the most survey limitation will be like the target. So in the as you know, in the northern sky there are only 45 GCs, but there are totally 160 GCs know, and I think this is one of the limitations of our survey.
Okay.
Yeah. Okay.
Yep. Good.
Mm-hmm.
Okay. Boop, 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 boop,
And
boop.
okay, so
Okay.
next come to the sensitivity. I think we can go through figure yeah, figure two. I also have something to say.
Good.
So
Okay.
GC fans had surveyed for over 7 years and for 41 GCs. And as you can see in the right, we have concluded the total number and the
Uh-huh.
count of the observations for each GC. And over the 7 years, GC fans um, has like come up with over 1,020 hours of observations for the disease. And here's all the members and colleagues in GC Fans has done very hard work and great efforts, I think. Yeah. So
Yes.
this data
I
will. Mhm.
I still have something to say. The first thing is that the dots in this figure is
Yes.
not present the observation length. It only means the observation is exist. And the second thing is that we collect all the data which is obtained when the telescope pointed to the global clusters. So
Okay.
that is not only our project. So, FAST have very limited time, so we do not have thousands of hours to do such a project. So
Right.
we collect every possible date and then search for pulsars. And another thing which is can be worthy to mention is that you can find some with some globe classes was observing frequently. For
Okay.
example, the M13 and M5,
Mm-hmm.
because those pulsars here is have very regular timing with other groups, and
Okay.
then when they have the data published, and then we also get the data to find more pulsars. You
Okay.
can find our more papers in the future.
Cool. Let me ask a question. What is some of the circles are lightly colored and some are more darkly colored? What does
That is only about the stacking.
Okay.
So the dots with some transparency settings, and when many dots stay together,
Got it.
you will see it.
Got it. Okay. Just wanted to make sure there wasn't some hidden meaning.
Yeah.
Good. Okay.
Okay, so
That's a
we
great
can
figure. That's a great figure.
mhm. Okay, so we can continue. Maybe we can go
Okay.
through the next figure, which is the integration time for each GC.
Okay.
It should
Got some
be
lovely
figure
equations there,
three.
people. You can check them
Um,
out.
Yeah, there are so
th-
many equations. Yeah.
this is very interesting plot, figure
Mhm.
3.
Oh yeah. Uh-huh. Okay, time.
Yeah.
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 Okay.
Actually, this figure shows the actual integration time for HGC and
Yeah.
the forecast theoretical integration time with different angles. Yeah, as you can
Okay.
see, for in GC fans, we try our best to integrate each GC as long as we can. So we will like with the longest integration time, so we have get a high signal to noise ratio, so to they will benefit to searching process. Yeah.
Cool. Okay. Very nice.
Mm-hmm.
Wow.
So maybe we can jump other equations in the sensitivity. We can just go through the figure 4. Yeah.
Figure four?
Yeah, there are so many equations and
I love equations. I love equations. But we'll go to figure here. Okay,
Mhm.
spin periods. Yes. Yes. Yes.
Mhm.
Yes, this
Okay.
is about the sensitivity.
Mm-hmm.
Yeah, so estimated from equation 1, and we can like estimate the sensitivity of 6 radio telescopes, and assuming the integration time is 4 hours, and with different DM values, which is dispersion errors. And as you
Yes.
can see, fast is the most sensitive to single digit radio telescopes, and
Cool.
it will like help to explore the wider space of the radio pulsars. And yeah.
Awesome.
Okay, yeah, I have a very quick
Hmm.
question for you. Why
Hmm.
other people do not find the pulsar M14A?
Okay.
Yeah, I think that's a very good question. So,
Right.
I think the
Okay, I will tell you,
possible
it is
reason.
out of our
Uh-huh.
visible sky.
Oh, okay. Uh-huh.
It is slightly out of our visible sky. The fact have a relatively large sky coverage than our visible, so we have
Mm-hmm.
several more chance to find new pulsars. But anyway, our
Yeah,
visible
yeah, I
is
see.
such a great telescope in the human
Uh-huh.
history.
Uh-huh.
Hmm.
Uh-huh.
Hmm.
Yeah, okay. Thanks for the reminder. Yeah. Yeah, indeed, FAST has twice the air observing air than RCBO. Yeah, so this
You
one
can
out
see
of the
some
three. Yeah.
some of our samples is still above our visible sensitivity. So our visibles is
Mm-hmm.
what a pity, and it should exist for a long time.
Yes. Yes.
Yeah, I think so.
Yes.
Okay,
That's
so we can
cool.
continue
Nice figure.
to yeah
Okay.
to
There's
next
M
part, I think.
and DMs. Yes. Okay.
Yeah.
Good. Okay. Now we got all that. Now we got to do a search. Okay. Table
Mm-hmm.
2. Okay. That was sort of in figure 3 there.
Yeah, this is all the telescope parameters used to
Mhm.
estimate the sensitivity in the last figure. So, yeah.
Yes. Yes.
Mm-hmm.
I put some numbers on that figure if you want to check it out.
Uh-huh.
Then we get
Mm-hmm.
the timings. Okay.
Yeah, so I think here are the pulsar searching and timing procedures we normally used in GC fans, and there are many details of how well we like searching pulsars in different clusters with different settings, and there are all the details, and I'm not introduce very detailed, but there are all the details. Yeah. Mhm.
Oh, uh-huh. Yep.
Okay.
Mm-hmm.
For the timing, we normally use tempo to time these pulsars, and here I want to introduce a script which called Sieve and Dracula, which are developed by Paulo Freire and Alexandro Ridolfi, and this script. These two scripts are very useful to time pulsars, especially with the pulsars with very long gap between observations.
Yes.
Sometimes we will like get multiple solutions for the timing. So this is a very useful script to like forecast the different gap in such kind of observations. Yeah.
Good, 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 good. Always good to get
I
feedback.
want to say why we use such a old code named tempo.
Right.
Because I read one of our courses, Professor Scott Ransom, in 2019, and I said he told me how to time a pulsar. And then we start from tempo, which is the code written many, many years before.
Yes.
And so I started the tempo, and then I also teach my student to use tempo first.
Okay.
The timing
Fantastic.
software now we have at least the tempo 2 and the Paint, and I believe my student would use all the codes, but I still prefer to use tempo first.
Yes. Yes. One usually goes
Yeah.
to it. One learns first. Yes.
Mm-hmm.
Yes, always.
Always. Very good. Good to give a shout out to the software being used, right? It's always good. Okay. And then we get
Okay.
a
So
summary of the pulsars. Okay.
yeah. So I think the most important thing we want to emphasize all conclude in figure 5.
Okay.
And here comes all the binary pulsars known in GCs, and we have plot the binary pulsars discovered by FAST. And as you can see, uh, for M15, M71,
Mhm.
as Zhichen Pan has introduced before. So this cluster is very special in this way. So it's a closest cluster within FastSky from us, and it's only for KTC. And actually, it's one of the lowest density cluster. It's like lower than
Okay.
10. orders of three, and some study will forecast there are less possibility to find pulsars in this cluster, but with fast high sensitivity, there are four binary pulsars, which is M71B2E found by fast, and A is found by Arcibo, I think, and as you can see, this cluster at the same time include the binary period.
Cool.
And it also concludes the longest orbital period with M71B and C, which
Cool.
is over 400 and 300 days. So.
Yep.
And at the same time, it even concludes the double neutron star candidate, which is M71D. And as you can see, so this cluster has many stories to
Sure.
say, and it's very special. And yeah.
Very
Okay.
cool. What are some of the lines on here? We've got a bunch of lines. We've got
yeah, actually,
tours,
it's
basically what's this line here?
These lines actually are reference lines and calculated for the access of the orbit. Yeah.
Okay.
One thing to add, which is because of M71B and C have a very long orbital period. So once we have its orbit, we want to know if it has the eclipsing phenomenon. So we wait for almost 1 year to catch the proper orbital phase, and then we confirm they do not have any eclipsing phenomenon. And so we do not know the orbital inclination precisely. But anyway, with the low mass companion.
Cool. Very nice. Beautiful. Beautiful. I love it. Okay.
And by the way, our course Polo suggests that the M71B could be originally the double neutron star system from the Globular cluster. And as you know, the Globular cluster have a very dense stellar environment. So the encounter rate will cause the binaries to be destroyed and reformed with another companion. So such a double neutron star system is not a common thing, and we are lucky to have one.
Yes. Yes.
Yeah, I think this most thanks to the lower density of this cluster and make the binaries can survive. Yeah.
Very cool. I love
Okay, so yeah, we can go through table 3, I guess, that conclude all the pulsar discoveries by fast.
Now we get into some of the great things. Okay, this is table 3. Let me rotate this so we get it. Okay, so this is the observed and derived parameters for M92.
Oh, yeah, table. Yeah.
Oh, I'm sorry, table 3. Sorry.
Okay.
My bad. Sorry. Okay, basic parameters.
Okay, so here we conclude all the pulsar discoveries by fast, and this includes 3 pulsar discoveries, and is not first discovered by Yujie Lian. And here I want to stress one special cluster, which is M53. And here are four pulsars found by Yujie Lian, and as you can see, this cluster is a distant cluster with no pulsars. It's about 18 kpc from us, and with fast high sensitivity, we can find more pulsars in these clusters. And this cluster is also a very low density cluster. So we found more binary pulsars in it, and which is very similar to those pulsars in galactic disk. And so we will discuss in the later to see what will different clusters with different density will have different pulsar distributions. Yeah.
Okay, I'm with you.
Okay.
Good.
So
okay, I will still add more. So actually, We have some newest update for this table. For example, we have another paper just accepted about the pulsars in M2. The details about those pulsars can be found there.
Okay.
And on the other hand, for the pulsars in M14, we are still preparing some papers. And for example, we already have the orbital periods for the pulsar M14B and C. And M14E, as already know as eclipsing
Wow.
right back, will be carefully described in the future paper.
Very cool. Okay. M14, M2 over here. Very good. Okay. Okay, good. What does I mean? Oh,
And
I is isolated here. Okay. Uh-huh.
yeah, and I suppose this year we will have the paper about the last maybe 2 or 3 pulsars in NGC 6517. It is extremely fun, and I suppose everyone, if you see the discovery plot, you will not believe it is a pulsar, and we use the timing to confirm it as a pulsar instead of observing it for multiple times because it's extremely fun. And I will leave this things to our next maybe APG letter paper.
Oh, we'll
And
come back to that. We'll come back to that. We'll come back to that. Okay. You got me on edge. You got me on edge.
extremely
Okay.
fun.
Very good. Table three.
Yeah.
Yeah, okay.
And
So,
okay, let me
you
rotate this
okay?
out of the way a little
Uh-huh.
bit. There we go. Table four if you want.
Okay, here we come table 4, and in this work we
Okay.
updated for pulsar timing solutions and solved the first phase coherent timing
Okay.
solutions. So here comes M92A and this is 67 and 12A. And in this table, we have updated uh, the positions and the proper motion of this system. And we also like measure the second spin frequency derivatives of the second pulsars. And as you can see, we have discussed in the text about the proper motion of these 2 pulsars are consist with the clusters proper motion. And
Good.
we have like try to find the X-ray counterpart of these pulsars through their positions and proper motions. And we have found for maybe we can go to next figure, please.
Cool.
And here's the
Okay.
positions of these pulsars.
Here we go.
Yes.
Okay.
Mhm.
Residuals. I mean residuals.
Oh,
Yeah.
here's the residuals. Yeah. Uh, I think in this figure, there's one thing to say is for the first 3 pulsars, there are ellipsing event for this binary system. So when the pulsars eliminating radio emissions towards us, and the companion in the orbit will like block the radio emissions, and we will lost the TOAs of this pulsars. So you
Okay.
can see there are delay in the timing residuals. Yeah.
And there's an interesting thing about the NGC 6712A. It
Huh?
is a nearly eclipsing pulsar, so which means you can detect the radio signal always, but there is a time of arrival delay around the orbital phase 0.25. And
Uh-huh.
this is cause our timing problem at very early age. And once we notice it, we are see such a interesting phenomenon.
Mm-hmm.
And I would like to say that we should have some more co-authors, but that pulsar is initially in the Professor Yan Zheng's paper, and
Okay.
we tried to join him, but finally we added him into the acknowledged list due
Okay.
to
Good.
working divisions.
Good. Good.
But
Good.
that is
Uh,
quite an interesting one, and
Geez.
this delay is different in different observations, and we can use it to probe the atmosphere of the companion.
Yes.
It is
Yes.
a black widow, which means can be a brown dwarf companion, and there's a chance to
Ooh.
observe
Ooh.
the brown dwarf.
Ooh. 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 That's a wild system. Okay. All righty.
Okay.
Good. Okay.
So we can go through to next figure. So
Okay.
actually, there are so many timing parameters in the text, so maybe we will just reference to the figure to introduce them. It's
Okay.
more, yeah, clear. And yeah, so in figure 7, so we have listed the positions of the pulsars in M192, NGC 67 and 12 and M71. So
Oh,
as you can see, the red star is the known pulsars in these clusters, and the blue circle just marked the known X-ray source in the Chandra data.
okay.
And the green cross is the core radius of the clusters, and the circle is the core radius of this cluster. And as you can see for M1928, so here is no X-ray counterpart for this pulsars, and it has been discussed before. And for uh, this cluster, there is a very strong eliminating X-ray source and screens all the other X-ray emissions in this cluster. So we shall not have chance to probe the X-ray photons from the position of pulsar A.
Okay.
Okay. So for M71, there is two X-ray counterpart for A and E has been discussed in formal papers. Yeah.
Okay.
As you can see. And for the newly timed, yeah, for the newly timed pulsar B, C, and D with the timing precision about 0.01 arc second, we have matched no X-ray counterpart for these three pulsars.
Okay.
Yeah.
Okay.
Okay, so actually in the results, we have updated the timing parameters of B, C, and D. So we have found these three pulsars are very interesting. And for B and C, they are the longest binary pulsars with the longest optical period. And B is over 400 days, and C is over 300 days. And this is very likely to the another longest binary pulsar, which is M53A. And that pulsar has an orbital period of 250 days.
Okay.
And as you can see, these three long orbit pulsars are normally found in low density clusters. And this gives us some hint about in such kind of low density environment, we could find more binary pulsars in this kind of clusters. Even those long pulsars has very large optical sections, which means they should have much more possibility to be disturbed by the encounter stars. But we have found these binary pulsars, their orbits are very stable and very like the galactic pulsars, which is involves isolated. So this gives some hint about the pulsar distributions in different density clusters. Yeah. Okay, so here comes, I want to say more about M71D. So
Yes.
actually, this is a very extrinsic double neutron star system. Sorry, it's a double neutron star candidate, and because we just solved the omega dot for this system, so that means we only know the total mass of this binary system. And it's 2.63 solar mass. And in this figure, we showed the mass distribution for this system with MCMC analysis. And as you can see from the constraint, we know the mass of the pulsar is around 1.2 solar mass, and the mass of the companion is around 1.4 solar mass. So it's very likely a neutron star for this companion. But in the future, we should use more. We should extend the timing baseline to get more post-capillary parameters and to get a very detailed mass constraint for the companion and the pulsar to confirm if it is a double neutron star system. Then we will probe the exact evolution of such kind of system in low density clusters. Yeah.
Right. In the strong gravity regime. Right.
Okay, so we can go through the next
Nice.
page, I think. Yeah.
Very good.
So in the next, we have discussed the cluster model of these three GCs.
Okay.
Yeah, we can see the next figure.
I'm just admiring
quite
its numbers
clear.
for a second.
Okay.
Okay, good. Okay, acceleration model.
Okay. So in these figures, there is a triangle which marked the pulsar's projected offset from the cluster center, and the y-axis, the y-axis is the line of sight acceleration of the pulsars, and the triangle means the maximum value for the line of sight acceleration observed from the pulsar.
Okay.
And in this figure, as you can see, there are two solid black lines.
Yes.
And actually, this is a limit estimated from the cluster model and is calculated from the current density profile of the cluster. And we can predict the maximum value of the line of sight acceleration from the cluster potential. And it sometimes will dominate the line of sight acceleration of the pulsars. And as you can see in these figures, we can see NGC 67 and 12A and M51D. The line of sight acceleration filled by these two pulsars are quite well fitted by the model of the cluster. Like in,
Gotcha.
yeah, and but for M192A, and the left for pulsars in M71. They show very large positive line of sight accelerations and exceed the prediction of the cluster model. So we believe that in these pulsars, their intrinsic acceleration, which means their intrinsic first derivatives of these pulsars will dominate.
I would tell you because I am the people who find this pulsar. M92A is a red back, which means it accreting the materials from the companion.
Yes.
So which cause it rotating changes.
Okay.
And so that's the difference. But the reason why we wrote it here is showing that the interaction between the pulsar and the companion in such a red-back system is obvious, which means you cannot say it comes from the gravitational potential to cause such derivatives. But in M71, you will see the totally different thing happened here. We have many pulsars which far from the prediction, and there should have something else exist.
Yeah, exactly.
Good, thank you.
So from the estimation of their intrinsic acceleration, so we can estimate the magnetic field strength and the characteristic age of these pulsars. And we have found especially in M71, all the pulsars show relatively large characteristic age, especially for M71D, as you can see in table 6.
Yikes.
the lower limit of M71D
Wow.
is 8.8 gigayear, which means this is a very old binary system and involved in the very early age of this cluster, and it should formed in the normal star evolution and come to double neutron star, but not formed dynamically like other double neutron star candidates, like in M15. And there's a double neutron star candidate M15C, which is a very young double neutron star candidate, and it's only account less than 1% of the age of the cluster. But M71D is a totally different example. Yeah.
Mm-hmm. I have to admire something here with an infinite lifetime, infinite age.
Yeah. Yeah, actually, it just come from the calculation because we don't know the.
I understand.
Slowly.
I
Yeah.
just admire infinite age objects.
Okay. So yeah, mhm.
Cool.
So
Nice.
maybe we can have a quick look about the discussion about M71B and the C
Okay.
in next section.
Yes, the eccentricities. Uh-huh.
Mhm.
Uh-huh.
Yeah, okay. So here comes the eccentricity for M71, B, C, and D. So here we just use equation 9 to estimate the time to produce the eccentricity of the binaries in GCs. So we can have a comparison between this time scale to its characteristic age to see if this system if it is a really old system. And as you can see, we can see the time scale to generate the eccentricities for M71 B and C is about 1.9 gigayear and 1.1 gigayear. So this value is very similar and agree with their characteristic age. And especially for M71D, we obtain the timescale is about 228 gigayear, which is much larger than the age of the of a general GC. So it indicates again this system is a very old system, and it's formed in the early age of this cluster. Okay, so for the next section, we have discussed the two longest binary pulsars known in M71. And as you can see, these two systems actually has a very similar optical characteristics, and they have similar competitiveness with the binary system found in galactic disk. And this means that this system shows a similar evolution link between the KSB rock lobe overflow and formed in the galactic disk. And these two binary system and together with the binary system, which is called M53A, that we have discussed in another paper. These three systems are all like the long orbit system formed in galactic disks, and they share the same evolution link. And so here is the minus conclusion is we can find more such kind of long orbit pulsars in low density clusters. But actually we haven't done some quantify the cross section of these long orbit pulsars to see how much possibility they will survive in such kind of clusters. So this is also our future work. We will discuss it in a very quantitative way. Yeah.
Okay.
Mhm.
To start, it's a start.
Yeah. So for M71D, so we have discussed this double neutron star candidate, and as we discussed before, this is a first old double neutron star candidate found in GC, and it's not likely form dynamically like the other candidates in higher density clusters. Yeah. So.
Right.
Yeah,
Right.
so we in the future we will time this pulsar more precisely and get another PK parameter to constrain its detailed mass. Yeah.
Yeah, definitely. Definitely got to
Okay.
follow up on that one.
Okay, and
Mhm.
let me add some.
Uh-huh.
So till now, the double neutron star system with a regular pulsar as the component is no more than 30, I think. So we at least provide one more. And there's several double neutron star or even the candidates in the global clusters, and we are likely to provide one more.
One
And
more,
it
yep.
is very real, and we definitely will keep monitoring it. But the orbital period is around 11 days, very long, which
Right.
means the post-capillary parameters is not easy to be measured.
Yes.
And we will see if we are lucky enough to measure any one more parameters.
Okay. Okay. Yes. Okay.
Okay.
Super.
Mhm.
Okay.
Okay, so after all these results, we have like a discussion of the whole sample of GC bands. And first, we have discussed a bit about the beam coverage and the sensitivity of this campaign. And as you can see, FAST has a beam about 3 arc minute, and it should cover nearly all the clusters within the sky. And
Okay.
it also has the ability to find the pulsars which is far away from the cluster center. Like there's
Uh-huh.
an example for M61E, which is found by the team of GPPS and timed by the team of Zhichen Pan. And so here is a hint about FAST has the ability to find pulsar far away from the cluster center, and the beam coverage is enough to most of the clusters. Yeah.
Cool.
I want to remind you that the FAST is a single dish radio
Yeah.
Yes.
telescope, so which
Yes.
means the beam size is relatively limited. So 3 arc minutes
Hmm.
is the diameter of the half power. So which
Hmm.
means that out of the such a region, you will still have some signal obtained by the telescope.
Yeah,
And
exactly.
thanks to the very high sensitivity, you will have chance to also get those signals. But on the other hand, it is not enough to cover the whole region of the global cluster.
Hmm.
So maybe in the near future, we'll have something else. For example, the array around the FAST to have a large coverage around the global cluster and
Okay.
see if we have missed anything.
Okay.
Hmm.
Good. Cool.
Okay.
Weak ones. Yes. Okay. Good.
Okay. So yeah, we have discussed very much about the fast sensitivity to the weakest pulsar. So maybe we can go through the next subsection, which is section 4.3. And actually, we can go through the figure in this section.
Okay.
Yeah,
Yep.
I think it's much clear to have a conclusion about.
Okay. Figure
Mhm,
10. Okay. LRC versus ROSI. Okay. Central
mhm.
density. Hmm.
Okay, yeah. So in this figure, we have plot all the 45 clusters with known pulsars, and especially the clusters with no pulsars in within fast sky. And in this figure, the x-axis is the cone radius of the cluster, and the y-axis is the core density of the cluster. And as forecast as formal work, these two parameters are correlated with the so-called stellar encounter rate, bigger gamma, and the so-called single binary encounter rate, which is little gamma. And these two parameters are the indicator of the low max X-ray binaries prediction in the cluster, and the possibility of the binary system go through a second encounter event. And as you can see in this figure, there are three red lines, which is about the little gamma. And the lower of the little gamma, which means the binaries in this cluster will go through a lower possibility to be disrupted by another stellar. And the blue lines represent the value of the bigger gamma. And as you can see, if the bigger gamma is larger, and that means the cluster will have a higher possibility to produce of low max X-ray binaries, which means they will have higher possibility to find more pulsars.
Okay.
And here comes one very interesting point, is that for most clusters within fast sky, those clusters located in the lower bigger gamma and the lower smaller gamma air. So this means, so FAST has found many pulsars, which is predicted has less possibility to find pulsars. And this means with fast high possibility, it's very important to have throughout and systematic observations for these kinds of clusters, and do not give up to searching pulsars in such kind of clusters. Another thing is that we have the pulsar discoveries in these clusters has proved that for the clusters with lower gamma value, which means the cluster with a lower single binary encounter rate, the pulsar distribution will be dominated by the binary pulsars. So this is very consistent with the observational result. So in this cluster, we do find more binary pulsars in these clusters, like in M71, there are 5 pulsars and all in binary system. And for this cluster, M71, there's another indication is that for the forecast from bigger gamma, this is not enough to predict the number of pulsars in this cluster. So we should consider more other effects which will influence the number of the pulsars in this cluster, because we have found 5 pulsars in, this cluster have 5 known pulsars in it, and it's exceeded the prediction of the bigger gamma.
Okay.
Okay.
I'm with you.
So so here is the main discussion of this figure. So
and don't forget the sky coverage. So sometime how we wish we can move fast to the southern hemisphere, so that we can have more global cluster to observe, and find more pulsars.
Cool. Cool. Very good. Okay.
So maybe we can come to next figure, which is discussing about the distribution of the spin period and opto period and its flux density for all the known GC pulsars. So as you can see, the left figure shows the flux density and the spin period of all known GC pulsars, and for 6 different radio telescopes. And the right figure shows the flux density and the opto period for binary pulsar distributions. So here we marked with red for the discoveries from FAST, And as you can see, for fast, the average flux density of this pulsars is obviously lower than the previous no GC pulsars.
Yes.
And so with fast high sensitivity, we have a chance to explore the lower space of the parameters. And for
Yeah.
so this is the same case for the binary pulsars. We have like more chance to explore the lower space. And as you can see, we also marked the pulsars in M71. So this cluster is definitely should be discussed more in the future about how what's the truth about this cluster has so many exotic pulsars. Yeah,
Exactly.
maybe some simulations will give some indications. Yeah.
Maybe. Okay.
Okay. So
Cool.
so we can go through the final figure. I think it's
Okay.
figure
Slide
12.
down to last figure, distribution of spin period. And here we have gamma ray SEDs. Okay.
Yeah. So after we have like we have known so many timing solutions for the GC pulsars, and Globular clusters are also known as a very good X-ray sources. So here comes the question is, if we can use the timing of the no pulsars in the clusters to fold with the no Fermi data to see if the clusters have any gamma ray positions of the pulsars.
Okay.
And here comes the result as for M192. And there are some studies indicate there is a possible gamma ray positions for these clusters, but in our work, we use updated timing solutions and folded by Dr. David Smith, and we have found no gamma ray polarizations for these clusters. So this means maybe the gamma ray emission from the pulsar is too weak to be observed by Fermi, or maybe we need further observations for these clusters. And this is the same circumstance for the last two clusters. We also try to follow the Fermi data with all the known timing solutions, but we found no gamma ray positions from the pulsars.
Okay.
So this is our effort to find any hint from the gamma ray counterpart of the pulsars. Yeah, maybe future works will give a much indications about how we can use the radio timing solutions to fold such kind of gamma ray positions. Yeah.
Make that correlation. Yep. Very cool. Very nice.
Okay. So yeah, so finally it will like go through the conclusion of GC fans. Yeah, so actually we have concluded all the discoveries in the 7 years campaign, and this GC bands has result in 60 new discoveries of pulsars, which is more than double the number of GC pulsars in the fast sky. And thanks to the high sensitivity, we have found more pulsars in lower density clusters like in M71 and in M53, which is also the longest GC with no pulsars. And so we have like discussed a bit about the pulsars in M71, and this cluster is very remarkable and containing the five binary pulsars with very special characteristics. And in the future, we will like use a more quantitative way to describe how such kind of long pulsars and extrinsic double neutron star candidates will formed in such kind of low density clusters.
Right.
Yeah.
Very cool. Very nice. Beautiful work. Beautiful.
Okay, so
Thank you.
here is nearly all the main stuff introduced in this paper. So actually, I have like not go through very detailed discussion and the results, but all the details are in the paper. And if anyone has any questions, I'm happy to contact with my email, and yeah, we can have a discussion. Yeah.
Very
They
cool.
can find my email and then I will
Mhm.
forward the question to you.
Mhm.
Very cool. Yujie Chen,
Yeah.
beautiful, beautiful work. Thank you so
Thank
much
you
for
so
walking
much.
us through
Yeah.
your
Thanks very
very
much.
wonderful paper. This is going to shed some light on globular clusters, especially those low density ones. Yeah, very nice.
Mhm.
Very good.
Thank you. And
Let's see. And you
uh,
mentioned well, in several occasions you mentioned where potential future directions. And so let me push on it a little bit at this point. And what do you think the prospects are for the nearest future? We mentioned this tantalizing APJ letter coming up. Are there other additional observations going on with FAST? Maybe there's some theoretical work that could be done, particularly in the evolutionary scenarios. And so where do you think we go from here, given this published article?
okay, so the reason why we have such an article because we have many the original reasons results that we needed to get this published. And then we have many things to do. The first step is timing all the discovered process.
Okay.
As you know, if we have 60 pulsar in total, timing them will need many or much telescope time.
Okay.
And it is not easy to propose enough fast time to monitoring all the pulsars, and we are doing it every day
Oof.
and every semester to get time. It seems that we still may have about 10 pulsars without the coherent, I mean the phase connected timing solution. The timing is a very important technical for pulsars. It
Yep.
will bring us a very precise way to measure the pulsar itself or the environment around it.
Mm,
And that's the thing we should do in the very near future.
cool.
And the next thing is that we are always keep updating our global cluster pulsar model because we are finding such a pulsars and we need to updating the model to help the future surveys. At least, for example, if we have the chance to observing all the global cluster pulsars, we should have the priorities to observing some very important targets first.
Yeah. Yeah.
And for the theory, I should say we are still have many exotic systems about the binary formation, about the gravitational related theories.
Yes.
And I would like to say here, my colleagues from the Shanghai Astronomical Observatories,
Uh-huh.
they find a very eccentric binary pulsar in the global cluster, which means we already have the eccentricity measured, and we need to get it published soon.
Cool.
And the good news is that they also choose the AAS journals. And
Good.
another thing also comes from their group, led by the Professor Zhang Zhongli, is that we may have a triple system.
Ooh. Ooh. Okay. Now you got my
And
attention. You got my
I,
attention.
I'm not 100% sure, but at least all the guys look at our data think it's worthy to try.
Wow.
And
Wow.
I think that's already enough.
Yeah, that's enough. That's enough. Very cool. Very cool. Yuji, you want to add anything?
Yeah, actually, except the future work I mentioned in the paper, and it's about the evolutionary link of the long orbit pulsars in low density clusters. And there's another thing we will like use the pulsar samples to probe the dark mass in the cluster center and to see if the dark mass is
Okay. Okay.
compound with like stellar remnants from white dwarfs or even an intermediate mass black hole. So here is another future work we will like discuss. Yeah. Mhm.
Cool. Cool. Well, it's going to be really exciting over the next couple of years as we really start leveraging, what FAST is finding in the analysis of them. So it's going to be a very exciting near future, and I really look forward to seeing this work come out in the AAS journals, of course.
And
Yeah.
actually, to add the only one sentence that the fast sensitivity is always exist. So maybe next time we will have more exciting things announced.
We can do another video. It's perfectly fine
Okay.
to do. Very
I
cool.
wish to.
Very good. Zhichen,
Yeah.
thank you so much once again. Beautiful work.
Thanks very
And
much for
also
the
thank you
invitation. Yeah.
to
Sure.
interview us and
Sure.
interested in our study.
Absolutely. And that will do, everyone. And I hope this made your astronomy day just a little bit better. And we will see you on the next one. Bye bye.
Bye bye.